Docker is an open source platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. The initial release of Docker was in March 2013, and since then it has become the buzzword for modern world development, especially in the face of agile based projects. The term Docker usually refers to a set of open source tools that allow developers to build and run containers individually or as a stack of related containers. A container is an isolated package that contains every needed to run a piece of software except for the kernel. Docker was originally written to work with Linux and has more recently been enabled for MS Words. Docker Incorporation is the company behind the open source Docker toolset. Docker builds a high level API over execution driver. The default execution driver since release 0.9 is Docker's own lib container driver. It's mainly written in Go language, and its source code can be found on Docker Hub. For a Docker installation on different operating systems such as Linux, Windows, or OS X means Mac OS. And releases have three types: stable, edge, and test. The latest stable version is 19.0.3.12, released on 25th of June 2020. Docker concepts. Now we can see Docker is a platform for developers and sysadmins to build, run, and share applications with containers. The use of containers to deploy applications is called containerization. Containers are not new, but their use for easily deploying applications is. Containerization is increasingly popular because containers are flexible. Even the most complex applications can be containerized because it is flexible, lightweight. Containers leverage and share the host kernel, making them much more efficient in terms of system resources than virtual machines because it is lightweight and portable. You can build locally, deploy to any cloud, and run anywhere. So it is portable. Loosely coupled containers are highly self-sufficient and encapsulated, allowing you to replace or upgrade one without disturbing others. So it is loosely coupled, scalable. You can increase and automatically distribute containers replicas across a data center. Secure. Containers apply aggressive constraints and isolations to process without any configuration required on the part of the user. Now you can see the difference between virtualization and containerization. Virtualization. It is a technique of importing a guest OS on top of the host OS. This technique was a revolution in the beginning because the developers can run multiple applications in different virtual machines, all running on the same host. This eliminates the need for extra hardware resource and enabled backup. We can easily recover in case of failure condition. We are looking on the diagram. This diagram shows complete reference for virtualization technique and containerization. It is also a type of virtualization at the OS level. While virtualization brings the abstraction to the hardware, containerization brings abstraction to the software. Containers are more efficient because there is no guest OS. Binaries and libraries means bins and libs of containers are running on the host. kernel, which makes processing and execution very fast, and the boot up time is also fraction of seconds. Now let us see what is Docker. Docker is a containerization platform which packages your application and all its dependencies together in the form of containers. So, yes, to ensure that your application works seamlessly in any environment like development or test or production. You can see the related application contains binaries and libraries. That one is app 1 is referred as a container 1, app 2 is referred as a container 2. Those are running on host OS only, so it is a container. Now we can see resources or memory utilization. In case of virtual machines, there are a total memory 16 GB and allotted to VM1 6 GB. VM1 is used 4 GB only and 2 GB wasted here, and second VM from 16 total memory it is allotted to 4 GB memory to virtual machine 2. Virtual machine 2 is used 3 GB only and wasted 1 GB, as well as in total 16 GB memory, 6 GB allotted to virtual machine M and VM3, and 2 GB is used VM3 and 4 GB wasted. Totally we will see memory used three applications in virtual machine 9 GB only, and wasted memory is 7 GB. 7 GB memory is blocked and cannot be allotted to any new virtual machines. In the Docker, in case of Docker, here also for example, total memory 16 GB is there, 16 GB memory, and with this 16 GB, app 1 allotted 4 GB memory, and it is not wasted any memory app 1, and 3 GB memory allotted to app 2, and 2 GB memory, 3 GB memory allotted to app 2, and 2 GB memory allotted to app 3. It is not wasted any single GB or a single byte of memory. Only 9 GB memory utilized, 7 GB can be allotted to new containers. That is the difference between virtualization and containerization using by VMs and as well as Docker. Building under development, how it is already I told, there is a host OS. If we want a new builds, we need to install multiple OSs, and we need to install separate libraries, and for that particular application, then it will be heavy and it will take more time. In case of Docker, if we want to create new builds, same OS it will use, and separate libraries for required for that application, and it will be lightweight because of there is no guest OS, and it will take very less time. Then next, integration in VMs. Integration in VMs is possible but costly due to infrastructure requirements, not easily scalable. Setting up each VM brings with an infrastructure problems. We will have the same problem if we have to set up multiple instances like Jenkins, Git, Ansible. It is also be a difficult task to configure the multiple tools in every virtual machine. With the Docker integration, Integration in Docker is faster, cheap, and easily scalable. Using Docker containers, we can set up many instances like Jenkins, Puppet, and many more, all running in the same container or running in different containers, which can interact with one another by just running few commands. We can also easily scalable by splitting multiple copies of 3 containers, so configuring them will not be a problem. How Docker works. In Linux systems, installation part is different, as well as OS X means Mac and Windows also. Installation is different. We need to download the installation commands for Docker website. Then we need to install required regarding OSs, required OSs on regarding servers, if we are using Linux servers or Windows or Mac OS. And Docker commands and work with Docker is the same in any OS or any environment. Next one is Docker. We can say Docker is the heart of Docker system. It works like a client server application by chooses the it works like a client server application by chooses the server merged type of a long running program called daemon process and the command line interface client. The REST API is the combination of socket IO and TCP IP connection. It used to communication between the client and Docker daemon. Docker next thing is Docker images and Docker containers. What is the difference? You can see now. Docker registry is the storage. Now we will see Docker images and Docker containers. Images can be related to an executable file. Images are the building blocks of Docker container. These Docker images are created with the build command, and these read-only templates are creating the containers by using the run command. Containers are the ready application that created from the images. Containers are the instance of images and they hold the entire package that is needed to run the application. Images or Docker images are read-only template used to create containers built by Docker users, stored in Docker Hub or our local repository. Docker containers are also isolated application platform. Containers everything needed to run the application built from one or more images. This is the difference between containers and images. And Docker registry. Docker registry is the storage component for Docker images. We can store the images in either public or private repositories. Docker Hub is Docker's very own cloud repository. The repository can be users' local repository or Docker Hub, so that multiple users can collaborate in building an application. Even multiple teams within the same organization can exchange their shared containers by uploading them into Docker Hub. Docker Hub is very smaller to GitHub. Docker registries store images. These are public or private stores from which you upload or download images. This can be done on Docker Hub, which is Docker's version of GitHub. Docker registries are the distribution component of Docker. Next we will see Docker architecture. Docker host. Docker host running the Docker daemon. Docker daemon is responsible for images and containers. Now, if we want to build a Docker image, we will use client to issue a build command to Docker daemon. The Docker daemon will then build an image based on my inputs and saved in my registry, which can be either a Docker hub or a local repository. If we want to pull an image from the Docker hub, which has been built by a different user by giving pull command, if we want to create a running instance for our Docker image, we will issue a run command from client, which will create our container. And Docker terminology, we can see Docker daemon. The daemons run on host machine. Daemons create and manage Docker objects, image containers, networks, volumes, data, etc. are the objects, Docker objects. The user does not directly interact with the daemon, but instead through the Docker client. Docker client primarily the user interface to Docker. It accepts commands from the user and communicates back and forth with a Docker daemon. Docker images. Images are used to create Docker containers. Docker provides a simple way to build new images or update existing images. Docker images are the build component of Docker. A Docker image is a file containing the code and components needed to run software in a container. Containers and images use a layered file system. Each layer contains only the differences from the previous layer. The image consists of one or more read-only layers, while the container adds one additional writable layer. The layered file system allows multiple images and containers to share the same layers. This results in smaller overall storage footprint, fast image transfer, faster image build. Now we will see Docker containers. Containers are created from Docker images. They hold everything that is needed for an application to run. Each container is an isolated and secure application platform. Docker containers are the run component of Docker. This is about the Docker introduction. Next video we will see them how to install Docker, how to work with Docker, and coming videos I will give them more knowledge about the Docker, how to work Docker, why the Docker is so popular nowadays. These things we will see on next videos. Subscribe my channel for further videos and like it, share it, comment it. Thank you.